Okay, everybody, we're going to get started with our Introduction to Geographic Information Systems lecture, first one for the semester, and what better place to start than at the beginning where we ask the question, what is GIS? I'm Jamie Alvarez, I'm the instructor, and I'm the voice you'll hear throughout the course of the semester in all of the lectures and the demonstrations, and this is how I'm going to deliver them. And I will also have a PDF of the actual lecture, so you can kind of use it as a transcript, if you will, of what I'm saying in the videos. So here we go. Let's go ahead and talk about what is GIS. This is what I would call a textbook definition, if you will. GIS is a computer-based system that can do a lot of different things. You can put geographic information into it. You can store it there. You can manipulate it. You can edit it, which you guys will be learning how to do. Display it and make maps, of course. And I've underscored analyze there because that's what we really do in geography. We do spatial analysis, and we will basically the culmination of our semester will be to begin analyzing geographically referenced data. But you'll notice that that data is there to support something, and the key there is that it's going to support decision-making processes. So GIS is a decision-making tool, and it supports those decision-making processes. So you can apply that tool to many different fields, and you'll see in this lecture right off the bat here, right at the beginning, that you can apply GIS to a number of fields. So even if you're not majoring in something like geospatial applications or GIS, you might be someone in environmental science or public safety, real estate. You can apply this technology to all of those different fields. So what does a GIS do? Well, it uses points, lines, and polygons as well as accompanying databases. So I'll talk about that a little bit more. Imagery and maps to represent features in the real world. And one of the things we have to understand is that any map is an abstraction of the real world. So when we talk about points, lines, and polygons, we're talking about what's called vector data. And we'll talk about vector versus raster here in just a few minutes. And then, of course, we'll talk about satellite imagery and scanned maps, which are a type called raster data. So two major categories that we'll address a little bit later on. But the databases behind that data is really the power. So what does a point in the real world represent? What does a line in the real world represent? What does a polygon on a map or an area on a map represent? And what is the information behind that? So that's the point that we're going to get at here as we go through the demo and as you go through the first demonstration video after the lecture. So GIS systems combine both spatial and attribute data. So what we would consider the spatial data in this case, points, lines, and polygons, and of course the imagery and maps are going to indicate what the spatial data is as well. But then what we call attributes in GIS, the attribute data, is stored in some form of a database, whether that's a database file or a large relational database management system, which we'll get into a little bit more at a later time. So spatial data and attribute data. The spatial data, what is out there actually in the real world, represented or abstracted in your GIS, plus the attribute or the characteristic information stored in a database, giving you the descriptive information about those features. So here's what it kind of takes form in a GIS. Everything's in layers in a GIS. Layers can be added to create a map, to create a composite overlay, as we're saying here. And so you can see that there are physical and cultural features. And as we kind of work our way down from the top here, we've got a topographic base. We might have some contour lines, but we may also have property parcels, zoning. Those are all what we would call cultural features. Those are human features. That's us sort of managing the space on the surface of the earth. However, we also have floodplains, wetlands, land cover, which are more natural or physical types of features. So we would store each one of those in a different layer. Soils, of course, survey control, that's going to be a human type of layer where we have control points out in the real world for registering our geographic data. And of course all of those layers, and of course these are just examples, but all of these types of layers come together to create a composite map that we can then use to analyze the relationship between the layers. So there may be a specific question that we're trying to ask and we're trying to answer at the same time. So we want to find out maybe which parcels fall within a particular floodplain. That might be a question that we're trying to do in an analysis, and of course we want to be able to answer that so that we can do some floodplain mitigation, purchase some properties, and potentially have people move out of a hazardous area. That's one example. So you kind of see where things are kind of going with this particular graphic here. So I like to use this quote here. GIS is a framework capable of integrating all levels of past, present, and possible future geographies. So of course, if we think about past geographies, we think about historical maps and historical data being abstracted in a GIS. Present data, of course, what is the current condition, and that's going to change constantly. A lot of times when a map is created, it's out of date as soon as it gets published. So the present, indicating what are present conditions, of course are going to change and they'll become part of the past. And then of course possible future geographies. Using this type of technology to maybe indicate where something could possibly have an impact in the future is a good example of how we could kind of use GIS to look at what we call future geographies. So that is by a gentleman by the name of Stan Openshaw. I like to quote him and use a couple of these quotes from him. And look at that date there, back as far back as 1991, several years ago now, where GIS wasn't as mainstream as it is today. But even then, we were saying that GIS is going to provide a platform for what we call doing geography, and I'm kind of putting the quotes in there. That's what geographers use as a tool to study the Earth. When you break down the term geography, geo meaning Earth, graphy meaning to write or to analyze, to describe, we're using this technology to do just that. Now, I've got a sort of what I might call an inspirational video here, the Geospatial Revolution video, a quick 5-minute trailer to a series of videos. I've put it in the module as well, so there is a link in the module. There's a link in the lecture here as well, so I won't click on it, but it's one that you should definitely take a look at because it's a nice introductory video, a short video that just kind of indicates what you can do with geospatial technologies, and it's a fantastically well done video by the Penn State broadcasting, public broadcasting, and I think it kind of puts in a nutshell the types of things that you can do with the technology that you're learning in this class. So a brief history. This is not a history class, but there are two components of the course where I talk about the history, some of the names and organizations, agencies that kind of gave birth or rise to GIS. And then, of course, in a couple of lectures, you're going to learn a little bit about the history of the software and how it's come to be, to this point at least, in terms of ArcGIS software, and some of the file structures that are still used today. That are part of the software. So that's going to be in a later lecture. But here we just have a brief history of some of the more important names that kind of get things going. Roger Tomlinson, he's known as the father of GIS. If you can imagine, Canada is a very large country. They have a lot of land to manage. So as part of the Canadian Land Survey, land inventory, back in the early 1960s, they thought of the idea to use a computer to start to store geographic information for the Canadian Land Inventory. Yeah, fast forward a little bit further into the 60s with Howard Fisher establishing the Harvard Lab for Computer Graphics and Spatial Analysis. So this is kind of one of the first labs in the country to actually start doing this. And of course, Jack Dangerman, as I indicate here on the slides, he's the president of Environmental Systems Research Institute, ESRI, or ESRI. They manufacture ArcGIS, and that's the software that is the focus of our course. So he's a graduate of this Harvard lab, and if there's a name and a face to remember in your beginning your journey here in terms of GIS, it's Jack Dangerman. ArcGIS and Esri software, they're the world leaders in ArcGIS software, or in GIS software, excuse me, and so that's a name that you're going to hear throughout your career using GIS. I've got the Urban and Regional Information Systems Association website here, their Hall of Fame specifically. I've already got that loaded up here into a web page, so I'm just going to kind of pop that over here. And just to kind of hit their Hall of Fame and see, there are some other major names in here in terms of what they've done in, for GIS over the many years. But if you click on Roger Tomlinson, you can see here Roger's a very tall man. Is still going to the ArcGIS conferences in San Diego, and you can see him around the lecture halls and around the map galleries, looking at and appreciating the technology and what it's come to be in the time since the time that he kind of started it. And it's funny to think of him. He's the father of GIS, but he gets up there and he gives his speeches, and he looks at everyone in the crowd and says that you must be my grandchildren if I'm the father of GIS. So he's a great guy, a real inspiration, and it's kind of interesting to think that here's the guy that gave rise to this technology, and you can see him on a regular basis at Esri's conference in San Diego on a yearly basis. Mention Jack Dangermond. All right, so there's Jack, and a lot of people do know him just as Jack. Fantastic innovator, and again, a graduate of that Harvard lab, and just a name synonymous with GIS. So that's one to kind of put in your back pocket and kind of remember. Sounds like a good exam question if you ask me, but Jack Dangermond is definitely one of those ones, again, that is synonymous with GIS. So I would encourage you to look at some of these other folks, some of these other names on their Hall of Fame. A couple of the bigger ones, of course, Tomlinson and Dangermond. And so you can also see up at the top of this website that I've got a couple of other tabs that I'm going to be going through eventually as part of a secondary video that talks about web mapping, and that's going to carry you into your first assignment, GIS on the web. The demonstration will also be done in a separate video, which is already up on Blackboard. So I'm just going to go ahead and jump out of this and hop back into the lecture over here. And think about the things that you can do with GIS. Preserving information from aging hard copy maps, of course. We're in this digital world now, and maps do break down over time. So you can imagine utilities, infrastructure, just like the maps, of course, break down over time. So we need to know where they are. And so having that technology to map utilities and infrastructure in a digital environment is crucial to being able to maintain that type of infrastructure. You can geo-enable non-geographic data. A lot of data exists in spreadsheets and databases, and a lot of time businesses, for example, store their customer information in a database that's just rows and columns, and that's what the database component is to GIS, just rows and columns of databases that can relate to one another. So a bunch of addresses have a place in the real world. Longitude and latitude coordinates have a place in the real world and can be visualized on a map. So that's one of the ways you can create some of this geographic information, and that's what we're going to be doing as part of this class. Transportation and routing, drive time analysis, absolutely, and all of that really leads into spatial analysis. We're analyzing the space on the surface of the Earth and trying to look at different relationships and the interconnectedness of both physical and cultural features, as we mentioned earlier. So I like to put in this slide, and I like you guys to just go ahead and take a few seconds while I'm in the middle of the lecture here to think about what are the 5 parts of a GIS. What could they possibly be? You need something to do GIS, and you have these 5 parts that I consider the main parts of a GIS, and some may not surprise you, and other ones may surprise you. So I'll give you guys a second or two, kind of give it a thought. And then, of course, the professor is going to go ahead and reveal it anyway here in the PowerPoint lecture. So when you think about GIS and what you guys are doing, what you're going to be doing as part of this class, the installation of the software that you did, you have to have hardware to install that software. That makes sense. To analyze anything, you got to have some sort of data or some sort of information. So, of course, we're going to require data. So we're going to work in this realm a whole bunch in this class. I take a very data approach. We get our software. We operate it on hardware. We are the people that go ahead and operate that system. So you need trained professionals who know GIS, and that's part of you all taking this course and being exposed to the technology. And of course, we are going to use the data to do some sort of an analysis, and that brings us all the way over here to this important part. The applications. What is the application? What are you doing? Are you doing environmental science? Are you doing public safety? Are you trying to deploy your particular data to the web so that the public can consume it and use it and make decisions? There is a reason for using GIS. There's an application for using GIS. So we can have all the wonderful hardware and software, really fast computers, but without data to put into those computers and into that software and a reason to do it and the people trained to use it, we pretty much don't have GIS. So these are kind of really 5 broad categories that I consider what would be the 5 parts of a GIS. So tools that you would use for GIS, well, we mentioned the hardware. So of course we would use computers and servers, printers and plotters. Absolutely, we're going to be printing hard copy maps when we use GIS. Plotters, printing large format types of maps. Digitizers, of course, scanners to get data into this digital environment. So digitizers and scanners, of course, are used to get paper maps into this digital environment. Of course, we mentioned GIS desktop software. We mentioned software in general, but of course what you're going to be using as part of the course is going to be desktop software, but of course this is working its way out onto the web. CAD software. CAD and GIS, there's a two-way street between the two of them, and I know some of you are registered for the CAD 154 course, and so there are things that CAD can do that GIS can't do, and things that GIS can do that CAD can't do. It's a two-way street though, because the data is interchangeable between the two different systems. So CAD definitely has a place here in our discussion, and we'll talk about that more as the class progresses. Multimedia, photos, video, 3D models, absolutely. Different ways to visualize our world. We incorporate that into our maps and into our web maps and into the maps that we do as part of final projects in this class, where you can incorporate not only a map, but you would pull in photos and tables and graphics and tabular information to support what your map is showing. The internet, again, the very first assignment in this course involves you going out on the internet and finding your own interactive maps, and so that's already in the module. You know what you have to do there, and I'm going to give you guys a couple of demos in a separate video to show you the kind of things that I'm looking for. GIS personnel, that's the people, that's you guys learning the technology and putting it into practice out into the job market and into your career fields. And of course, we take this stuff with us everywhere we go. Smartphones, mobile technology. The geospatial revolution video really focuses a lot on that. So we're all walking around with smartphones and mobile technology in our back pockets these days. So that definitely has a place here in our discussion when we talk about GIS. Our software, what software are we going to be using? Well, I've mentioned it already. We're going to be using ArcGIS. So I like to use the umbrella sort of as the analogy here. ArcMap and ArcToolbox and ArcCatalog are three components of ArcGIS, and this is on a desktop environment. We will use ArcMap heavily throughout the course. We will do more with ArcCatalog as we move on, and then eventually we'll hit some of the geoprocessing tools within ArcToolbox. But I like to use the analogy here, not just the umbrella analogy, but if you guys think about Microsoft Office and you have these different tools that do different things. Word, Excel, Access, and PowerPoint do different things, but they're all part of that suite that is Microsoft Office. ArcGIS is the suite that is made up of these three primary components. There are other components that are used for 3D analysis, other types of extensions to the software, but this is our foundation for beginning our journey with doing GIS. And again, my analogy here is Microsoft Office and the different components. That's not to say that ArcGIS is the end-all be-all of GIS. I have actually in my career have used Small World. They kind of have a stronghold on the utilities industry. They have a tendency to use Small World GIS. MapInfo is another example of GIS software that I've come across, and I've embedded these links. I'm not going to visit them all now, but I encourage you all to take a look. Autodesk, the makers of AutoCAD, also have their own version of GIS, and of course Intergraph, one of the companies that is also heavily involved with CAD software, also has their version of GIS. So definitely encourage you to take a look at these and get to know other systems that are out there, but our course will be focused on ArcGIS. So I mentioned earlier our two categories of GIS data. So you can see an aerial photograph here of the Carnegie Mellon campus in Pittsburgh, Pennsylvania, and that's what we would call raster data. So rasters such as satellite images, aerial photographs that have been scanned, just like any photographs that we take on our phones or our digital cameras, are raster based. They are pixel based. Whereas when we talk about vector data, again, we'd mentioned points, lines, and polygons earlier, and then of course the attributes. And these are just some basic, very basic attributes that you might apply to a point, a line, or a polygon. But of course that point might represent one fire hydrant in a series of fire hydrants in a fire hydrant system. And so when you would click on that point, you would not just get the size, type, information, but when it was installed, when it was last serviced, things that would be pertinent to the fire department to know about its fire hydrants. With lines, with polygons, perhaps we would use these to delineate boundaries. And of course, the database behind those points, lines, and polygons is the real power to know the descriptive information behind that data. So you'll see that in the demonstration. I'll interact with some of the tools both on the web and also on ArcGIS Desktop, and we'll kind of start to build that mentality of points, lines, and polygons and the accompanying attributes, and of course using raster data as our backdrop to a lot of that. Where do we get GIS data from? Well, we mentioned digitizers and scanners, and so taking paper maps, pulling them off of the internet, but of course data exists out there that could be purchased, donated, which would be wonderful. There's lots of free data out on the internet, and that's part of the first assignment, to go out there and see what's out there, but also created by the user. And guys, you guys are going to do a lot of this in this class. I've mentioned earlier that this is a data heavy type of class, so you're going to be creating it, you're going to be working with it, you're going to be editing it throughout the course. So we'll be prepared to do that. We mentioned databases, tables of data, rows and columns that just otherwise would have no geographic component in Excel or in Access or some other type of database. Geo-enabling it and putting it on a map is what we want to accomplish. GPS is ubiquitous in our lives. We use GPS for many different applications, and so no exception there. GIS data, one of the sources could be data collected using a GPS out in the field. And then of course there's remote sensing, which I'll talk a little bit in more detail here so that we understand the technology. But remember that with remotely sensed data, which is going to be all raster based, is going to act more as a backdrop to this course. We're going to be focused more on vector data. However, the raster data that comes from the remote sensing side of geospatial applications is used for analysis, but also acts as a backdrop to our use of vector data in this course. So what is remote sensing? Well, this is what I like to call the long, nerdy NASA definition: the acquisition and measurement of data or information on some properties of a phenomena or object or material by a recording device not in physical intimate contact with the feature under surveillance. Wow, that's a mouthful. Well, if you think about it, our satellites that are in outer space, they are not in direct contact with the Earth, and they're taking images of the surface of the Earth. If you take that concept of not being in direct contact with an object, you get taking a photograph. You get taking a digital photograph or a digital image with your camera. You get a satellite flying over the Earth and taking information about the Earth and recording it. So the really basic definition, of course, is reconnaissance at a distance, gathering of information at a distance. We're not in direct contact with the object. And so we break remote sensing down into two different types. Passive remote sensing, where the sensor is detecting the naturally reflected energy from an object. In this case, we're talking about satellite imagery. We're talking about energy, visible and non-visible electromagnetic energy reflected from the surface of the Earth and collected by a satellite. So satellite imagery, aerial photography are examples of what we call a passive remote sensing system. Whereas you'll see here that we have an active remote sensing system that generates its own device. And a lot of us are probably familiar with radar. Our planes and our boats typically don't bump into one another because of that. We know about radar because the police use it to detect our speeding on the highways. So they're not coming in direct contact with us. They use a device that uses electromagnetic energy to detect our speeds. The same thing with with LiDAR. That stands for light detection and ranging. Light detection and ranging. So what happens there is that a plane flies over with a laser device attached to it and basically hits the surface of the Earth with thousands and thousands of point locations, and it returns an X, a Y, and a Z. So basically a longitude, a latitude, and an elevation value is returned to the plane. And of course we can use that to develop three-dimensional views of our of the Earth. And this is just happens to be a post 9/11 shot of the lower Manhattan area. You can see ground zero right there after the towers had collapsed, and you can see a lot of the other areas around downtown Manhattan. And so this data was collected using this LiDAR technology. So just a couple of examples both of remote sensing, active and passive remote sensing, and of course a couple of examples of active remote sensing systems. Again, the device generates its own energy in that case, whereas with passive remote sensing, we're looking at reflected energy from the sun. So using the magic of PowerPoint here, I'm going to just kind of put together a quick little example of where we're going with using these various layers of information. So I've got municipalities here within Hennepin County, Minnesota, as an example. I'll turn on another layer, and there's a bunch of census tracts. So now we can see where populations are more focused. I'll pop on lakes, so now we'll start to see bodies of water. And so I'm kind of going somewhere with this. I'm not just making a map here. I want to get to a point where I use this information to make some sort of a decision or put together some useful information where maybe some action needs to be taken. So now let's add another layer to that. And again, we're storing all of these different features on an individual layer for each type of theme, if you will. Polluting companies. Now we're looking at maybe some environmental impact analysis where we're looking at polluting companies and their relationship to bodies of water. What about where those polluting companies are relative to where schools are located? Now we're starting to derive not just some data here, the layers are the data themselves, but also some information that could be used for a decision-making process. And out of all of that, potentially a map that could be used that shows where polluting companies are within 2 miles of a school, or schools within 2 miles of top polluters. And maybe that's a place, again, where we want to make a focus. We want to take some sort of action and maybe do some remediation and figure out how to maybe stop a polluter from putting pollutants into the atmosphere, into the environment. So just a quick, really quick environmental application, or maybe a social application of GIS. But if you look at this list here, this is not a comprehensive list. This is just so many different ways you could use the technology. And so I'm sure a lot of you come from these different types of backgrounds and would like to apply GIS to these different types of disciplines. These are numerous applications, and so we kind of say at the bottom here, wherever spatial data analysis is needed. And so we do that in geography. We use GIS as that tool, and these are just a smattering of the types of applications that you can apply it to. So I've got the demo video that's up on Blackboard. Go ahead and take a look at it. I do have 3 demos in there, and I'm only showing 2, building and analyzing a tree park inventory, and also the CCBC 25-foot policy on smoking, which is now actually an old policy, but it was a spatial question that I wanted to ask, and I had one of my students ask it in the past, and so I'd like to demonstrate that to you in the demonstration video as part of this module. So that's a separate video from here. And then what I'm going to do is another separate video. I'm going to give you a couple of examples of GIS on the web, so take a look at that video as well. I'm going to hit all 3 of these URLs and interact with them in that video, so take a look. A couple of different applications of GIS on the web, and of course that'll take you into assignment number 1, where you have to find your own example that is similar to what we're showing here. So go ahead and jump into those other demo videos, and we'll move on from there.